Good evening, everyone. It's my great pleasure to welcome you all here on behalf of the UCT UK Trust. As you know, this is our flagship event, and we're delighted that we have such a fitting attendance in such prestigious and magnificent surroundings. We also have an inspiring program, as you will find out soon. In fact, as we were coming here this afternoon, we heard that the Prince of Wales had just left from attending a meeting downstairs, and I'm sure had I had the opportunity to tell him about this program, he would have cancelled his next engagement and stayed for it, but I didn't get the chance. Also a special welcome to some representatives from Investec who are here, and thank them for their generous sponsorship, not only of our events, but also in the London SA community more broadly. We're also very pleased tonight to have Sarah Archer here. Many of you know Sarah. She's at the back there in the green. Sarah is the Executive Director of the Development and Alumni Department at UCT. And this presentation will also be filmed and used by Sarah and her colleagues for other alumni groups. The scheduled part of this evening will be a 45-minute presentation from our two speakers, and then we will have a 15-minute Q&A session on research. Then we will move on next door for some drink and some canapes and some socializing. As always, there's a lot going on at UCT, and I do encourage you to, any questions that you may have about UCT, do raise them with Sarah, with our speakers, Angela, myself, our other trustees who are here tonight, Frank Berman, Charles McGregor, Paula Walter, and Bronwyn Glavin, and let's talk about all things UCT. As the program notes state, we have two extremely distinguished academic speakers this evening. But what can't come through from the program notes is the vigor, the rigor, and the personality that they bring to bear on their work. But this will become apparent shortly. I've known Val Mizrahi for several years as the wildly successful head of UCT's best-known research institute. But I'm actually very glad that she's not doing that job anymore, because her new role, in which she is essentially responsible for fostering research across all faculties at UCT, is, to my mind, the most important and promising development in research at UCT for many years. So we look forward to hearing from her about that. I haven't known Deshen for nearly as long, but I've certainly heard about him for quite a while now. I spent a lot of time on campus and talking to UCT people, and a while ago, his name started coming up frequently in conversations, usually in the context of excellence in critical areas. And I'm sure my recent experience tells me that that buzz is not misplaced, as you will shortly find out. So can I please ask you to welcome, first of all, Val, and then Deshen.
Good evening, everybody. It's just special to be here with you, an enormous privilege and pleasure to be talking about my favorite subject and my favorite institution. I'm a research scientist. I was here a year ago when I became a fellow of the Royal Society. It's a special place, and I'm actually staying in a bedroom upstairs, and I didn't know that Prince Wales was around today. Had I known, I might have come downstairs and asked to have a selfie with him at least. But we've entitled our talk today, which I'm going to share with Deshen, Africa-Centered Research with Global Impact. And what we're going to do today is share with you some vignettes which illustrate some of the key features of our research enterprise. I'm only going to talk about rankings in one slide, and I'm here talking to a bunch of people who are UCT alums, who know our university well. It's common cause. We all agree and accept that UCT is the leading university on the African continent. And I want to put to you that it is research excellence that is a key determinant of UCT's excellence and UCT's global standing. Why do I say that? Our research enterprise is defined by a number of key distinguishing characteristics. Firstly, as you'll hear through the vignettes that we have selected to talk about tonight, the research that we do is focused on problems that are of relevance locally. However, the impact is global. We're not just working on things that affect us in Cape Town or in South Africa or in Africa. And as you'll see by these examples, some of the impact of the research is astonishing in terms of the magnitude of people taking note of what we're doing. Very importantly, and linked to this first point, is the fact that UCT is particularly well placed to work on certain topics. And we'll call this comparative advantage. And actually, I put advantage in inverted commas because in the area of health, for example, we've got major problems. In the area of water security, we have major problems. These are not advantages to society, but they are put us in a almost unique position to be able to apply the best thinking to tackling some of those problems. Unlike institutions in the global north, research and development of people are completely interlinked. And the people development I'm talking about here is senior advanced expertise. Research is dependent and works hand in glove with postgraduate training, masters, PhDs, postdoctoral fellows. We use research as a vehicle to develop high-level human capital. We do it in Africa, and we do it for Africa. We are highly interdisciplinary. The research is highly, highly collaborative. That will be exemplified by the stories we'll tell, and very flexible. I'm not going to talk specifically tonight about what happened during COVID. I'll be happy to chat to people afterwards. But the flexibility of the research enterprise that, at least from my field, which is health sciences, built around 3 decades of research around HIV, allowed us to move very, very rapidly. And I think it is, again, common knowledge that South African science batted way above average in tackling critical questions as related to COVID-19. So flexibility is important for adapting and moving into new areas of opportunity, but also new areas of threat, which is what COVID-19 demonstrated. Ultimately, the research enterprise is about the people. It's nice to have nice buildings and infrastructure, but it's about the people. Innovation, resilience, and entrepreneurship are the key attributes of the research leaders at our institution. Now, UCT has created a number of strategic focal areas as part of the Vision 2030, the research component of it. You can read for yourselves what these are. They fall in 5 broad areas. I'm going to touch on the first one of Healthy in Africa, nature-based solutions and advancing Africa. Not to say that the other 2 are not important, it's just that we've got limited time tonight. But also, in addition to those which are individual research themes, there are a number of cross-cutters. Data science is very big, and I'm delighted to share the talk tonight with Deshen, who's going to be talking about exciting advances in the area of artificial intelligence. The university also creates a framework into which scholarship can be embedded through strategic networks. UCT belongs to 3 networks, ARUA, IARU, and WUN, and you can see by the color coding, those colors are located in countries in which we have partner institutions. So in other words, there's an underlying agreement. So if a researcher at UCT wants to know, is anything happening between UCT and Berkeley, for example, or between UCT and Makerere University, you can look at this map, and a framework for doing collaborative research exists, not to say that we don't do most of our research bottom up. In other words, this is not exclusive. We work with the best people depending on where they are. We also participate in global multilaterals. Here's an example of the Africa-Europe clusters of research excellence, and just a couple of months ago was announced these so-called cores, clusters of research excellence, that are a partnership between ARUA, the African Research Universities Alliance, and the Guild, which is a cluster of European universities. Again, tonight I will touch on some of the work that's coming out of these, but you need to know that UCT is co-leading some of these, which are in areas of particular strength at our university. So tonight we're going to spotlight 4 areas. I'm going to talk to you with a handful of vignettes, the illustrative only, in health, the intersection between health and climate, and the intersection between those two and water. And then Deshen will talk about AI, which actually cuts across all fields of research at UCT. And the stories share a number of common features. These are all fields of research that are built by visionary entrepreneurial scholars. They exemplify that key attribute of why do this at UCT? Why? Okay. What is the advantage of being at UCT to do this? They all show very steep growth trajectories, in fact, almost growing faster than our ability to support the research enterprise. And very importantly, something you might not know about UCT is to be promoted as an academic at our university. Well, at every university you should teach, you should do research, and you should contribute through service to your institution. UCT has a fourth pillar, and that's called social responsiveness. That means engaging your scholarship with the non-academic community, civil society, government, industry, NGOs. In order to have impact of one's research, that social responsive element is crucial. I spend a lot of my time working with industry and government, okay? And so the way in which we judge our success is not just by the number of papers that you publish or the number of citations that your papers get, which is typically a global north way of thinking. So each of the examples we'll illustrate show influencing policy and practice. Health. We're a country that faces a quadruple burden of disease, which are all colliding with each other. Non-communicable infectious diseases dominated by HIV, AIDS, and tuberculosis, but not exclusively. Maternal and newborn, infant and child mortality, and tragically and particularly problematic in the Western Cape is the problem of trauma and injury. These are colliding epidemics. UCT researchers are working in all four of these areas. And if you don't remember anything from tonight, I want you to remember one thing, that your university, my university, last year, and looks like this year as well, for the last 6 years, was the university outside of North America that received the largest number of grants and the highest dollar value of research grants from the US National Institutes of Health. What is the NIH? This is the funder, the organization charged with the responsibility of health research in the United States. They fund intramurally in campuses in Bethesda, Maryland, extramurally to all American universities, but they also put some money outside of the country to fund research that is best done externally. We get the most. I mean, if that doesn't make you proud, what does? Okay. And this is really being led by UCT's exceptional research in infectious diseases, HIV, tuberculosis, as I said, built on a tragedy of an infectious disease burden, pediatric infectious diseases, public health, and psychiatry doing some extraordinary work, which can only and is best done in the communities that we serve in and around Cape Town. I'm a tuberculosis researcher, so I make no apologies for starting with some ideas about what we've been doing on the TB front. And I don't use the word groundbreaking lightly. I think scientists like myself are very risk averse to hyperbole. Okay. But this is truly groundbreaking. When you make it to the front page of the New York Times, you know that this is groundbreaking. Well, maybe. I'm not so sure in today's world. But what is this study? Understanding the problem of tuberculosis. It is the leading natural cause of death in our country. It's just horrible to think that. We're a middle-income country and more people die of TB than of any other disease. So Robin Wood, working in the Desmond Tutu Health Foundation, established in Masipumelele, this township, peri-urban township near Cape Town. He established this facility, indicated over here, to study the aerobiology of tuberculosis. Okay. Understanding who is transmitting to who, when, and where is this happening. And there's a lot of background to why this became such an important problem. And very importantly, I was involved in this partnership with the MMRU. It's a research unit that I'm still the director of. We are microbiologists working together with clinicians and engineers, set up an experimental system to try to capture the organisms that are produced in a person's bioaerosol, when they speak, like I'm doing, when they breathe, like we're all doing, coughing, singing, okay? you produce different types of bioaerosol. And to cut a very long story short, and this has been published in a number of very, very prominent publications in the last few years, you put an individual into this box. It's a personalized clean room, and you put a mask over their face, a cone. You get them to breathe or to sing or to talk. You capture the bioaerosol and you put it under a microscope. And what you're looking at here are these sausage-shaped structures, and the biologists and the clinicians in this room will recognize this is the tubercle bacillus, okay, which was discovered by Robert Koch 130 odd years ago. This is the causative agent of TB. So we can find these organisms and see them and count them, okay? And you can do this analysis on different people. Does a person actually have tuberculosis, or if they walked into the clinic for some other reason? And what is the dramatic finding is that, as shown on the right-hand side, just breathing produces most of the bacteria that are produced by a TB patient. Just breathing. The dogma in the textbooks, 90 years, cough is the symptom of tuberculosis, and cough is how it's transmitted. Well, I'm sorry to say, just breathing is how it's transmitted. So significant is this work that it has influenced the 2024 research strategy of the National Institute of Allergy and Infectious Diseases in the US. Work coming out of UCT, out of a township where TB is very prevalent. We are also home to the world-leading research sites testing and understanding how TB vaccines might work, okay? We've all, if we are UCT alums, we would have had the BCG vaccine. I'm sorry to tell you, it doesn't really protect against TB in adults. It's good for protecting against TB meningitis in infants. But we need to do better. And SATV, the South African TB Vaccine Initiative, a UCT-based, entirely soft-funded research group, they fund themselves through competitive research grants, ran a number of clinical trials. You don't need to know the details. I want you to focus on first in the world. And shown on the right-hand side over here is a critically important trial that demonstrated for the first time in decades a positive signal for a new TB vaccine. And if you read the news and follow some of what's happening in the health sector, you will know that the Gates Foundation has just put in $500 million, and the Wellcome Trust down the road here in Euston Road, another $150 million to do a phase 3 trial on this vaccine. The evidence base for that massive investment came out of and was led by UCT researchers. Again, 3-4 years from now, when the signals start coming out of these trials, I want you to remember the evidence base came from our university. In addition to testing interventions that have been developed elsewhere, other people's vaccines, what we've been able to do at UCT is build a formidable platform for human tuberculosis immunology studies. And what I'm indicated over here, and forget about all the scientific details unless there are clinicians and scientists who want to read this stuff, the key take-home message here is that the SATV group developed something called an adolescent cohort. They took 6,500 kids in and around the Worcester area and other places in the Western Cape, tracked them from older children through adolescence and tested them for whether they become infected with TB. The good news and the bad news is we all get infected with TB. So essentially, pretty much everyone gets infected, but a small subset go on to develop disease. And by doing some very sophisticated immunological studies in collaboration with a team at Stanford University, you can compare those who control the infection from those who progress the infection. And they came up with an idea of the antigens, the pieces, the proteins in the TB bacterium that are associated with certain types of immune cells that are dominant in those that are controlling the infection. And so now you're all aware, many of you would have had an mRNA vaccine for COVID. First in Africa, first for TB, a researcher, a young Zimbabwean in our institute at UCT, Munyaradzi Musvosvi, has developed together with colleagues at Wits University, stitched together 4 of these antigens, made an mRNA vaccine. It's been packaged at Afrigen, which is the WHO mRNA hub in Cape Town, and it's gone into animals for testing, and it is eliciting an immune response. I mean, we are going from basic research, fundamental discovery research, to implementing novel and developing novel interventions. Highly, highly innovative science. I've talked a bit about adults, touched a little bit about adolescents through the adolescent cohort. I now want to highlight and put the spotlight on this other very important piece of work that's been done in adolescence. And this is the work of Linda Gale Becker. Many you in the medical field might know her. She is a force of nature and a world-leading HIV researcher. She recognized, she and her team, HIV incidence amongst young people in sub-Saharan Africa is disproportionately high, and yet the clinical trials that were done for prevention of infection, so-called PrEP, with antiretroviral drugs, all done in adults. Do they work in adolescents? So she set about to test this. And cut a long story short, they ran the very first oral PrEP study in heterosexual adolescents and showed that the PrEP is feasible, acceptable, and it is safe. The results of this study not only led to approval by the local authority, SAHPRA, but influenced profoundly the Federal Drug Administration in the US. So this is now globally approved. Local relevance, global impact. Again, adolescents. Moving down in age now, the Drakenstein Child Health Study, the brainchild of another brilliant woman scientist, very highly decorated, Professor Heather Zaar from the Department of Pediatrics. Heather was interested, and her colleagues interested, in understanding and setting up a cohort of mothers who were pregnant and tracking the development in utero, neonatal, so antenatal, neonatal, following through early childhood and into later childhood, and sampling in the Drakenstein, which is a district in the Western Cape. You can see from the images there, it's a very poor district, and understanding what are the exposures that these mothers and their infants and children are experiencing, and how is this impacting on the diseases and how they're doing, what is their cognitive development, their neurodevelopment during childhood, early childhood and late childhood. And in connection and in collaboration with the UCT Neurosciences Institute, you haven't been to UCT recently, go visit. It's a spectacular new institute, about 6 years in existence now. There's been pivotal studies on developmental neurosciences, looking at two important exposures that these infants and young people in Drakenstein are experiencing. The one is HIV exposure without infection. In other words, neonatally in utero, the baby is being exposed to HIV through the mom who is HIV positive, but the baby does not come out being infected, but they've been exposed. Or alternatively, anemia, which is nutritionally based problem, okay? And what they've shown in both cases is that those exposures are impacting profoundly on the development, the neurological development of these infants. And so this work is providing the clinical evidence base that is advocating to optimize interventions in pregnant mothers. Okay, so I mean, this is about human development and getting an evidence base to say, how can we impact in our impoverished communities? The fourth pillar of the health problem, of course, is injury and violence. And here I want to just illustrate, just with a few of these images here, the work of a remarkable research unit, the Gender and Health Justice Research Unit, also entirely grant and donor funded. And this is led by Lillian Arntz with a small, formidable team. And you can see the work here of what they're doing. Some very important studies, the first national prevalence study on child abuse, violence, and neglect in South Africa. Their research and their findings are changing laws on domestic violence in South Africa. Okay, they're working on how their work has impacted sexual and reproductive rights of women in prisons. Okay, this is embedding oneself in the heart of the problem and coming with conclusions and policy changes. So well respected are they for working across 17 African countries that the GHJRU has observer status at the African Commission for Human and People's Rights. I want to switch gear a bit now and tell you about health and how it intersects with climate. Do you know that temperatures across Africa are expected to rise at twice the rate of the rest of the world? We are in the eye of the storm. We are going to receive the problems and are receiving the problems before other places. And yet, we don't really have ways of understanding what heat adaptation can be done, is being done. How does one adapt to this kind of environment? And so I highlight here the work of, again, two visionary scientists. They're both supported as AXA research chairs. Mark New in ACDI, the Climate Development Initiative, in the science faculty, and Laura Dugas, who works in public health. They came together to set up a study called HAVIA, which is funded by the Wellcome Trust. And what they're aiming to look at is to try to build up an evidence base for understanding the long-term health impacts and adaptation mechanisms for people who are most vulnerable in these environments, manual laborers and informal settlement dwellers. And so you can read here what the types of measurements that they're taking, the type of impact assessment that they're going to be doing. But you need to really understand clearly the impact of the intersection between climate and health is arguably one of the most important areas of research, because we're moving much more quickly into these catastrophic situations than any of us had predicted or even expected. That leads me into the second major theme around climate, and here to feature the work of ACDI. UCT does climate research in a number of different areas, but ACDI's work is located primarily in the impact of climate on development. And ACDI was set up only 12 years ago by Mark New, who came back to South Africa after having a faculty position at Oxford. And he is just an extraordinary scientist. And his work that he's done is aimed at facilitating and extending climate change research and education, but doing it within the context of addressing development challenges in Africa and viewing it through the lens of Africa. And as we know, much of the climate science and the climate advocacy has come very much from a global north perspective. They're involved in Arua. They are now leading one of these Arua's clusters of excellence with the Guild. A couple of examples of the projects they're working on here. They're working together with Climos, two other South African universities. Climos is an association of Belgian universities and the South African Adaptation Network. And here the idea is to fill in adaptation research, climate adaptation research, fill research gaps, and put a big spotlight on developing young people who've got the information and the understanding to be able to go out there and implement the types of changes and the types of policies that we know are going to be necessary for health adaptation. Very, very strong educational push with young people. So you can see all of their images are just about workshops and education. Ascend, another UCT graduate, Chris Trisos, became a Rhodes Scholar and came back, and he came back to ACDI. Why did he come back to ACDI? It was the best place for him to do something like this, which is utterly inspiring. Okay, I've been learning about this work and just feel humbled to work alongside people like this. So what Ascend is aiming to do is to create an enabling collaborative framework for research policy and practice. And the idea is that climate science, there is so much data coming in. And, we'll hear a bit more about AI and its link to climate. Integrating that data and pulling out what's important so that it can influence and accelerate the implementation of changes. And again, Ascend has got very much a strong leading from Africa for Africa through an African lens. And this is again, a person who's benefited greatly from advanced education here, but I feel very fortunate he came back home. Nature-based solutions. This is the intersection of climate and water. Okay. So we've been talking about adaptation mechanisms, but also in the area of climate, very important is to understand mechanisms, nature-based solutions that can reduce risk and reduce vulnerability to climate change. And the focus of this particular project, TES NBS, is to look at the role of these water towers, high-lying areas. Okay. These are the areas of these mountainous areas that are high-lying hills and plateaus. They provide a water supply to the lowland areas. And the idea with these kinds of projects is to see how can one work particularly together with communities. The imagery shows you where this work is taking place. South Africa has a water crisis. Too much, too little, too dirty. The drivers of the problem are indicated on the left-hand side, underpinning everything: poverty and inequality, fragmenting of the water governance situation in the country, intense storms. I mean, you've seen what's happened in the last couple of years with storms and floods, inability to manage flooding. Anybody who was in Cape Town recently would have lived through day zero. I ran a research institute with many laboratories where we had no water. Absolutely terrifying. So we're dealing with an enormous problem here with respect to water. And Bob Scholes, actually from my former university, Wits, one of great environmental scientists, quotes on the right-hand side, and this is back 23 years ago: the availability of water of acceptable quality is predicted to be the single greatest and most urgent developmental constraint facing South Africa. And so what are we doing in this area? There's a lot of interest in harvesting stormwater, using cities as supply catchment areas. And this is a project called PAUSE. This is run through another one of UCT's institutes called Future Water, and it's done in collaboration with colleagues in Europe. And the idea here is to come up with low-cost retrofitting of stormwater ponds. All the work is being done with large stakeholders, embedded in communities, co-creation with communities. And this is illustrating the type of social responsiveness research I was talking about earlier. If you bring people from the communities on your research journey from the get-go, implementation of any policy is that much easier because they co-created together with you. And so the aim of PAUSE is to develop pathways and ultimately, so water-sensitive design, the process, the city is the destination. My last slide, I'm going to leave you with the water that you and I produce, which is urine. And just highlight innovation coming out of UCT. This, you can see how delighted they are. This is Dylan Randall from the Faculty of Engineering and the Built Environment with two really, really outstanding students of his. And what they developed was a waterless urinal, 25-liter waterless urinal. It does not need to be connected to sewage. And you rig the thing so that you don't get odors, that you can decontaminate, that you can kill any pharmaceutical products that are in there. They're able to take from 4 of these, you can make 1 kilogram of fertilizer. We produce a lot of fertilizer in our urine, And that fertilizer can be applied in multiple different ways. But there's more to it than that, because what's left behind can be converted into bricks. The so-called biobrick innovation that came out of UCT, and you can see within 2 years, the compressive strength increased about 20-fold. And you can now produce from urine fertilizer and bricks. So this is again an example of taking otherwise waste, and asking in an era in which we need to think about sustainability and conservation. I just absolutely love the story. I am now going to hand over to Deshen, who's going to talk you through AI, and then I'll come and wrap up at the end. Thank you.
I was just telling Val that we're moving from urine to AI. So, so good evening, everyone. So I'm just going to say a few words about AI and what we're doing at UCT about AI. So I think everyone's aware of the astounding pace that AI is moving at. And of course, this is something that's very relevant to Africa. So AI has huge potential for solving some of our development challenges in Africa. But there are some serious problems that we have to deal with. So the first thing is that we need to make sure that in the future that AI is not Africa is not just consumers of AI, but also that AI must be created in Africa for Africa. But we have limited resources, and if you look at the huge investments that are being put into AI in the global north, how do we build this capacity and capability in Africa, and and to make sure that we're not left behind? What we should do is try and develop somehow a critical mass of AI researchers, innovators, and the next generation of academics who can teach AI. And the way to do this, we think, is to build agile ecosystems. We can't go it alone. You have to get the different universities, institutions, industry, academia, and government coming together. But of course, this is not easy to do. I'm just going to tell you about the AI research unit. It's been running now for 3 years, and my colleague Tommy Mayer and myself, we are involved in it. Tommy is a world-class researcher in the theoretical aspects of artificial intelligence, specifically knowledge representation and reasoning. And I work, and I'm very passionate about the applied side. And together, we work on a completely different spectrums, completely different spectrum of the AI space. But this has provided a very interesting and very synergistic kind of partnership. So one of the things that we do, and we think this is absolutely crucial when we talk about ecosystems, is we set up a national AI center in South Africa. So the individual computer science departments, if you're going to think of it, are too small in the country. And what we really thought, if we want critical mass, we have to work across institutions. It's a very interesting story. So Tommy was based at the CSIR. I was based at UKZN, my former university, and we knew each other and we worked well together, and we thought, let's set up this partnership. We approached the ministry, the Department of Science and Innovation through the CSR, and we set this up. And this seemed to work well. And in 2015 and 16, we went to the Department of Science and Innovation and proposed expanding and scaling this up. They were very interested in this idea, and then we proceeded to do this. At that point, we decided that the best place to actually do this was at UCT, and we both moved over to UCT. We set up the office, and so the hub is at UCT. Our two groups, the Adaptive and Cognitive Systems group, that's my group, and Tommy's group, in Knowledge Representation and Reasoning, and of course, we both lead the center. So it's got broad areas or groups led by senior academics at the other universities, and we've worked very well. We've been running in this extended form from 2015, 2016. So it went through further expansion, and most recently, it's now seen, because of the increased relevance of AI and the importance of it, it's seen as the flagship program by government to build AI capability. So we have support from them over the next 10 years in government's decadal plan, and we're busy trying to scale this up even further to create it for it to become a distributed center of excellence. So just a little bit about the now going into the what we do in the AI research unit in terms of the research that we do and our focus. As computer scientists, we don't produce these diagrams. Someone else is able to. So Tommy works on the theoretical side. So he comes from the blue sky side, which you see on the left. And the idea is, how do you take these rapid developments on the theoretical side, the techniques that are coming out, and how do you accelerate that into actual technologies that can help us to deal with development challenges? Tommy is an expert in the symbolic or knowledge representation reasoning, which is also can be considered the symbolic approach to AI. What most people are aware of is machine learning, the data-driven, with AI techniques, learning from large amounts of data. But the knowledge-based one is also or the symbolic AI is also very important. And this actually is more human compatible. It tries to take human expertise and encode it into rules or logical rules that computers can use. So these are the areas. I'm not going to go through it. I will touch on a few of this in an example that I'll show you in terms of one of the projects we're working on. But here's the applied side of the research, making its way into disruptive technologies. And these are the areas. So we have many partners in each of these areas. And as Val said, it's cross-cutting. So talking about the ecosystem, we know about AI. We certainly don't know about health. I told one of our partners, please do not ask me to speak to a medical practitioner. I'm not sure it's the right thing to do. And so these partners work. So the idea is that we bring in the technology, they tell us what the problems are, and then we create this kind of a cycle in terms of an ecosystem. So we give them some technology, and also we help to develop their capability in AI. In health, there's one organization that we're very proud of, Gembi Health Systems. One of their key technology was actually, we co-developed it in my lab at UKZN. We did this at a fraction of the cost that it was being done in the global north. It's something called a health information exchange. This can actually, it's the engine room, if you want to think of it, of a national health information system. All the data coming in from all the different facilities and types of data, it's like a mediator to make sure that it all gets to the right place in the right format. Gembi is now grown. It was a startup, and it's now like a startup, not-for-profit in the technology space, and now employs more than 100 staff. It works in about 10 countries. It even works beyond Africa. There's a few others which I'm not going to talk about. I think I might just mention the Western Cape Department of Health, and we working with them to actually introduce AI into the architecture for the Western Cape, the public health system with all the patient records in the public health system in the Western Cape. There's a startup. We're also working with a mining company, and we've got some good results there for mine processing, which we're helping them with. So now I want to get a bit more into the technical side. I guess a good AI talk wouldn't be worthwhile if I didn't show you some cool tech or some ideas. As Val said, we definitely have moving more towards the human-centered type systems. What people are really worried about, and I think is in the media, is these autonomous AI systems, about the killer robots that's going to do strange things. And that's not the AI we want to work with. So we want to work with what we call augmented AI systems. And this notion of an augmented AI system is where the AI works hand in hand with the human and amplifies the human intelligence rather than replace it. And this creates almost a new type of intelligence where the AI learns from the human and the human learns from the AI, and that's quite a powerful partnership. A good example of this, which you all use, is your Google Maps. There's sophisticated AI going on behind Google Maps, and when you go and put in your destination, it does this real-time planning. It takes into account traffic patterns in real time and adjusts. Is huge amounts of AI being used, but you don't see it. All you do is use the interface. So that's a very, very good example of how an augmented AI system would work. And then the other thing that I'm very passionate about, which we work in my group, is about creating what I call a robot scientist or an AI researcher. I'm in the Faculty of Science. I'm in computer science. So, of course, when I speak to my colleagues about AI, I tell them you should be worried about your job, not what's going to happen in society, because this is what we're working on. They don't find that very amusing. This is, of course, very difficult to do, and that's why it's such a nice, interesting problem. Can you actually create an AI that can help with science? And there have been some efforts, like the robot scientist and automated statistician, and there is a new method from, it's called theory of method in philosophy of science. It's a new scientific theory of method. It's called the abductive theory of method. And so we looked at this and we said, hang on, this looks very similar to the two branches of AI, the knowledge-based and or symbolic AI, and the machine learning, the data-based AI. So how it works, and I'm not going to go into too detail, I tried to abstract it out. So if you've got the physical world and you've got some sensors or observations coming from it, so the data, you clean the data or prepare it, And then you've got algorithms that can identify patterns and that are occurring in the data. And what we're really interested is unexpected patterns, patterns that look a little bit strange or they're new. And these phenomena, we could then try and find out what is really happening. Is it really something new that's happening? And now we've got some knowledge. We've got access to the current theories about how the world works and what we know. And then we say, well, hang on, with what we know, can we actually explain this new pattern? And if we can't, then there's potentially a new theory, something new that we can learn. And then, of course, we'd need to integrate it to make sure it's compatible with the old theories or the old beliefs. So interesting enough, this, what I'm saying, is actually the core of this new atom abductive theory of method. And this really is what the data-driven branch of AI machine learning does. And this really is what the knowledge-based systems, that branch of AI. Of course, there's some things here that to actually do theory construction is a lot more difficult. So there's a lot of work to be done. So this is where we see the AI community going. You've got the human-computer interaction, new interfaces like digital twins and Internet of Things, which I'll talk about in a little while. And then you've got the AI systems, and we think this is going to converge. The interface with the human, the cyber-physical systems like Internet of Things and digital twins, and of course what's happening in AI. So this is the blue sky idea. So I worked with the CEO of Djembe Health Systems, our partner. He brought the public health side. I was telling him about what I think is happening in AI. And in the public health side, there's a convergence, as Val might have mentioned, between health and the environment. And the idea is to have a holistic view of health. But not just that, it's also to look at a more preventative health approach. So don't wait until someone gets sick to put all the resources in the facility. Try and preempt this to do a more preventative approach. The idea of a digital twin, very briefly, because I can see I'm running out of time, I can talk about this forever, is if you think of Google Maps, and if you think about the model that Google Maps has in the back end. So now think about it, you've got in a city, let's say in the city of London, you've got vehicles, the traffic speed in every point in the road. That's a massive, massive model. And now you've got it for the entire world. So that's a huge model. And as something happens on the road in real time, this is being updated. But not just that, it's doing predictive modeling. It's seeing where the traffic is going to go, and it can also rewind and do the kind of analysis of what happened in the past. So this kind of backward and forward simulation is the idea of what you can do in a 3D digital twin. And I'm going to leave it at that. And now if you think with the AI, 3D digital twin, imagine what you can do for controlling epidemics. And like, for example, if we had that during COVID. I think I'll stop there and I'll hand over to Val. Thank you.
So we hope that you've enjoyed these vignettes that we've shared with you this evening. And what do we need? Okay, we need you. We need you to be our ambassadors to spread the word. Okay, to spread the word about our university. This is where the science is being done. This is where this research is being done. We need support, and support can come in many, many forms. We need to support for continuity, to innovate, to adapt, and ultimately to grow. Much of the research we shared with you tonight has been soft-funded, self-funded. These are people who are raising their own grants competitively, largely from international sources. And in building this research that we've shared with you tonight are coming a lot of really outstanding trainees. I'm humbled to see the excellence across Africa, from across Africa, emerging research leaders who are the ones who are going to be here 10 years from now. Seed funding. Critically important. Deshen is a classic example of this. Had he not received seed funding a few years ago from a donor, enabled him to do what he's shown you tonight, leading a major national initiative on AI. seed funding can make the difference, keeping a person in place or we lose them. And ultimately, of course, we need space and we need infrastructure. And I would put to you that whatever the size, the impact that any donation can have, this leveraging impact, the confidence that it builds on the recipient is of immense value. So I want to thank you for being here tonight. It's wonderful to see this room full. And Deshen and I are happy to take questions now, and we will be here the whole evening. So if you don't catch us now with questions, we'll be circulating in the room next door. Thank you, everybody. Questions? Deshen, do you want to come up here? Okay.
One.
Ah, there's a roaming microphone. Okay. Questions, anyone? Yes. Yeah.
Question for Deshen. Your work sounds amazing, brilliant. It's very exciting. You said that AI needs to be created in Africa. I wonder if you could expand on that, because my instinct would be to use the platforms that are coming out of America and apply it in Africa. So I just want to understand more about what you mean by creating it in Africa.
So I think the way to understand is the difference is computer scientists create algorithms and create technology, and then everyone else uses it. And if you kill computer science in Africa, it's a huge problem, because it means that you won't have a software development community. And so that's the one issue. The other issue is the culture, the diversity, the communities in Africa are very different from, so we noticed this in digital health. So I mentioned that technology we produced, we actually did it with the countries. So we actually developed it in Rwanda, and we tailored it for those settings. On the health side, which I've worked in for 20 years now, I think, the famous failure for a medical or health information system was in the Limpopo province in South Africa. And this was exactly that. It was IBM trying to use, again, I probably shouldn't mention the company. Sorry. Oops. Yeah. So it was, and I don't blame them, because what happened is they had a platform, and then they thought that the hospital would work in a similar way, because that's a reasonable expectation. And it did not work. And of course, there's been other failures, but the really sad thing is this is used in the academic literature as the reference failure. So, yeah. So we really need to, and I'm not saying that we will produce all the AI. That's impossible. We're not going to compete with the platforms that comes out of Google and Meta, etc. We would use them, but we also need to be able to produce our own AI, some fraction of it. And I think that combination will be very powerful.
Thank you.
Question at the back there. Yeah. Terry. Hi. Former PhD student of mine.
Hi. Good to see you again, Val.
Great to see you, Terry.
My question is not to you, to Deshen. So you talk about creating AI in Africa, presumably because we want to represent ourselves as well in this field. But my question really is, how do we address the challenge of transferring our biases into the AI? Because you've talked about augmented AI, where the human being teaches the AI and the AI adapts. How can we prevent transferring our cultural biases into the AI?
That's, of course, a very difficult question, but I can take a stab at it. And I think it's linked to the first question. So so your bias comes from the community you embedded in my view. And again, if you use an AI that was developed in a completely different community, which was biased towards that community, and then you try and use it in another community, and we've seen lots of examples with computer vision, etc. And if you try and just say, well, we can just use this AI in the other community, then that's a transfer of bias in my view. In terms of subjective bias, I don't think AI can solve bias, human bias. What it can do is now there's some very powerful AI techniques which can detect bias. And that actually, I think, can help. So maybe my ideas on, in terms of the way forward, one is when you create the AI, take into account the local population, do it hand in hand with the population, and make sure that the human who's in the loop is not a biased person. You put people with bias in decision-making positions. I think that's probably where, and then you don't just need the AI. That person should really not be in that position.
Other questions? Yeah, there's a hand up back there. Yeah.
Thanks. I'm a bit nervous to ask this question because it's kind of going in a bit into the negative sphere, but I was recently speaking to one of UCT's IP specialists, and she was saying, and it just kind of triggered when you said, Val, that we need to talk about the research and what's being done in UCT. And she was saying that a lot of the time there are certain things that, because it is an academic institution, that you can't talk about some of the innovation and things that are being developed and discoveries that are made and solutions. And she was talking a lot about some of the things, particularly in the kind of medical fraternity that were coming out, and that sometimes they, like UCT's, prevented from obtaining some kind of patent or being able to put it out and actually used. And a lot of time, the kind of big medical companies are waiting for a certain amount of time to then be able to, take those discoveries and monetize them. And all of that important, clever stuff is happening at UCT. It can't be spoken about, or that like 10 years has to pass and then you can find out that actually it was a UCT professor who discovered something. I mean,
So look, I mean, you're highlighting an issue regarding technology transfer and our capacity to do tech transfer at a level that is commensurate with the level of innovation that's actually happening in the institution. And I've had some discussions this week with Paul Kamleben from heading the UCT Trust here, and this topic has come up repeatedly. South Africa IP law is not particularly user-friendly. We are also subject to dealing in many cases with places and organizations that are far better equipped and capacitated than us. I don't really buy this argument, and maybe I haven't understood the question properly, that we can't talk about the work. Of course, there's some work that one has to keep under wraps, and you do keep under wraps, but there are good mechanisms in place for ensuring that patentable work. I mean, I led an institute which the lion's share of patents coming out of UCT came out of our institute. People with good ideas were patenting their ideas. How much of that has actually translated into a revenue stream for the university is another story altogether. And we're not a university that's got the level of resource that allows us to just patent and hold patents. Patent can be a financial hole for you. A patent becomes useful when it's realized, okay? And I think we are learning. We're on a very steep learning curve. I think there's been some really exciting examples out of medical technology, but for instance, bioengineering, development of heart valve replacements, development, I was telling some people out of our institute, of a new medical diagnostic that can detect subclinical sexually transmitted infections. We are playing in a sea swimming with sharks, okay? And one has to be very careful. And, the issue, of course, if you're training PhD students, is you want them to be able to publish their work. And I think that some people sometimes get a little frustrated that they can't speak about their work, they can't show their chemical structures and so on. But I personally don't think that the situation is quite as serious as the way that that it was portrayed. I put it down to capacity. And I've visited many other universities around the world that have got this seamless, they've got IP scouts running around the institution all the time, listening to seminars of postgraduate students and coming in and saying, you know what, we could do something useful. And it's not just about monetizing for the inventor. It's about creating a third stream of revenue for the university. And I think that UCT, given the amount of innovation, could do a lot better. Okay, so I've got access to, and again, another UCT alum, a top IP lawyer in New York who often gives of his time pro bono to help us, because when you're up against 5 lawyers from a competing company in New York, you want to have your A team on board, and sometimes tapping into people like you is what we need to do. Okay, hope that answers that question. Yes, yeah. Question over here.
Just a quick, 2 questions, but just a quick point on IP. Patents are only as good as you can exploit them. It's all very well holding them, but you only make the money from them when you commercialize the research.
Absolutely.
And I think a lot of academics forget that as well. They go, oh, I've got the IP, I've got the IP. That means nothing.
Absolutely.
There's no money in the bank from that. My first question is how do you go about connecting research back to learning and teaching?
Yeah, great question.
So you've got students in the classroom today, you've got some world-leading researchers.
Yeah.
How does that research inform
Yeah.
what the students are learning in the classroom? That's the first question.
Yeah.
The second one is around this public engagement piece.
Yeah.
I mean, what you presented today is just bloody marvelous.
Yeah.
But how are you going about communicating that value of the university to the general public and to alumni to build engagement, to raise awareness about impact, but also to then build engagement and buy-in and get the support that you need?
I'm with you. Thank you. So great questions. Integration of research into the teaching enterprise. My sense is that it's happening better in some places than others. There is, particularly with so much of the research being soft-funded, there is no obligation on a soft-funded researcher to teach. However, if you want to get promoted through UCT, you teach. So we had a culture, and I can really speak for my own institute and the faculty, where many of our top researchers would get involved in some teaching. Medical faculty is easy because you don't have vast numbers of undergraduate students, but some of my best occasions is when I stand up in front of a large class and talk about some of the excitement of science. We're also doing a lot of curriculum review constantly, and actually you can't teach modern biochemistry today without talking about systems biology, for example. So I'm quite comfortable that our best research is impinging on teaching. Where you run into problems is the interdisciplinarity issue, because as we know, universities are built, they're empires. They're built where the faculties have power, are king, and departments are queen, and institute directors do all the work and have no responsibility or authority. And I lived that life for 13 years. So because the funding flows, the organizational design is about teaching a discipline. How does one teach across disciplines? This, for me, is a big challenge. It's recognized at UCT. We're discussing it extensively through the University Research Committee. We're alert to the problem. It's not unique to us. It is a global problem. Some institutions have done away with departments. Some highly experimental models are being played with. Postgraduate schools are some of the things that people are talking about. I mean, in my research unit that I led and still lead at UCT, we had chemistry students from science faculty coming to learn biology of TB. But the funding went to the chemistry department in the science faculty when the student graduated. And you know, when you're fighting for scraps, it becomes a very undignified squabble, okay? So we've still got to figure this out, okay? But I'm comfortable that the best research is getting aired. Lots of seminar programs, okay? So again, most of the teaching is impinging at postgraduate level, but the curriculum is adopting new thinking. The second question about community and public engagement, and these are two very different things, okay? When one engages with community, which is what we do extremely well, these are the people for whom we are doing the research. This is who we serve, the poor communities around our city. And engagement there, in terms of social responsiveness, is bringing people in. How can you run a vaccine trial in Worcester when you're asking a mom to bring forward her baby to put the arm out to get an experimental vaccine? The only way to do that is to have massive amount of trust. The trust comes from years of involvement with the communities, knowing we are not going away. We are there. And when you see some of the children growing up and becoming UCT students, you know that you're part of the same family. So that is essentially community engagement. Public engagement, depending on who your audience is, are we doing enough of this? I mean, I just had a survey today led by the social accountability group in the Faculty of Health Sciences asking exactly this question. How much time did you spend talking about your science? You know, we use the conversation, which is this the publication forum. Some of the UCT people get prizes every year. Some of their pieces are read 1 million times. Mark Mendelsohn, who was here earlier for this AMR symposium, he's written definitive pieces around antimicrobial resistance and antibiotic stewardship. The message is getting out, and he's using publications, but geared towards being a communicator to the public. Many of the top flight research groups are building science communication into the undergraduate curriculum. In fact, I'm very proud in our institute, we have a public engagement module in the BSc Honours program. It's unheard of, okay? And it's actually started by another former PhD student of mine who has built a massive program called EWOZA, which is public and intersection of public and community engagement. We are doing science education. We're teaching people how to make a poster. And you know where it really struck us was in this period of COVID, where I remember talking as an institute director, and I thought, my goodness, we've got all these health scientists. We just need to give people agency. Give them well-curated facts about vaccines and drugs and what works and airborne viruses and so on, and they will go into their communities with a message. Well, it was a dead flop because they were getting their messaging from the preacher in the church on a Sunday, okay, who's not a scientist and not an infectious disease doctor, okay. And we're coming back and saying, I don't want to take this vaccine because it's the sign of the devil. So, you know, it is very complex. The trust deficit that you experience enormously in the US between experts and what's the so-called elites and everybody else is enormous. It came to South Africa. Vaccine hesitancy was a big problem. It's something that we're fighting with as we get measles outbreaks, for example. We've got to do better, okay? But you also have to value it. You know, if you're only valuing a publication in the Lancet and you're not valuing the time that a person is spending going out, giving public lectures, going and talking about the science, going and promoting like what we do here, and asking for you to have agency so that you can communicate the message. It has to be valued. It has to be supported. And we can always do better in this area. I see Paul's getting antsy because we are between you and the canapes right now. So I think we'll probably stop there, okay? Unless there's some other urgent question. Okay. Happy to communicate with you outside. Thank you, everybody. Okay.
Thank you very much to both Val and Deshen. That was really extremely interesting, and I'm sure will provide a lot of food for continued questioning. So please let's move over and do that. Again, thank you all for coming. Thank you to Investec for sponsoring. And as always, thank you very much to Angela and Amelia for all the hard work that they have done in connection with setting this up. So please make your way through and enjoy yourselves.